Hi guys, welcome back to Leaving Cert Geography Plus. In lesson 1.3, we're going to progress to more Leaving Cert based content, which is very important for short questions and 20-mark questions and big components of essays also. So before we kick off, I want you to pause this video and I want you to think of any 3 keywords that come to mind from a revision lesson on junior cycle plates and the structure of the Earth. Take about 10 seconds. All right, here are some keywords I've listed. First one here is subduction. So this is the concept where 2 plates collide. The denser plate subducts or is pushed down into the mantle. The plate is recycled and it adds extra material to the mantle. At subduction zones, you can have fairly destructive earthquakes and active volcanoes. Think the Pacific Ring of Fire. So next one I have here is a conservative plate boundary. So a conservative plate boundary can also be known as a transform or transverse plate boundary. Here you have plates that are generally going in the one direction and one can clip into the other. Pressure starts to build up. When the pressure is released, an earthquake can occur. It can be a pretty devastating earthquake. Think San Andreas Fault here. Last keyword I've written here is another plate boundary, a destructive plate boundary. So at a destructive plate boundary, you've got 2 plates that are colliding. So these 2 terms here are kind of connected. So you've got a couple of different types of destructive plate boundaries. You've got continental to continental plate boundaries, collisions. You've got oceanic to continental, and you've also got an oceanic to oceanic. We'll go into a lot more detail when we see this in lessons to come, when we get to chapter 2, when we're looking at plate boundaries. So you could have written anything there, but again, just a quick recap on what we did in the last class. So the main component of this class is having a look at the structure of the Earth in more detail, looking at the core, the mantle, and then also having a look at our crust. So the first area we're going to have a look at today is we're going to look at the core. Okay, so the core here consists of the inner and the outer core. So the inner core is solid. So it's a solid component and consists of iron and nickel and sulfur. So the outer core surrounds the inner core and it consists of molten iron and nickel. So the temperature of the inner core is said to be in and around 5,000 degrees Celsius, and this is around the same as the surface of the sun. Next one we're going to have a look at here then is our mantle. So a lot of key terms, keywords within this slide here that I'm just going to highlight as we go through can be important components as well for short questions, 20-mark questions, as we see later on. So the mantle is the middle layer of the Earth. Your convection currents are in play in the mantle and these move plates. So convection currents, key term, will be a basis of all essays from your plate boundaries to your volcanoes, your earthquakes, your fault mountains. No convection currents, no movement of plates, no phenomenon that I've just discussed. So convection currents cause endogenic forces, which cause earthquakes, they create fault mountains and also volcanoes. So the solid part of the upper mantle and the crust together, so 2 kind of components. So your solid part of the mantle and the crust, this is known as the lithosphere. So this is something that can come up as a part of a short question. What is the lithosphere? So the lithosphere is the solid part of the upper mantle and the crust, and this is known as your lithosphere. So the upper mantle, so below the lithosphere, is known as the asthenosphere. So the upper mantle, where convection currents are in play, known as the asthenosphere. Now, the next one we're going to look at, so the division between the upper mantle and the crust is like a line. Okay, and this is known as the Moho discontinuity, or it can be also known for short as the Moho line. So a couple of key terms, keywords there to remember. So endogenic forces here are important within this, as I've mentioned already, and they're the pressures within the Earth and their internal movements. Okay, and again, 2 components not to get confused between is the lithosphere and the asthenosphere. Okay, these are 2 keywords students often get confused between. So the lithosphere, just as a reminder, is the crust and the uppermost part of the mantle, whereas the asthenosphere is the denser, weaker layer below that, below the lithosphere in the upper mantle. So just know the difference between both there. Now we're on to our crust and what's going on in the crust. So the crust is the thin outer layer of the Earth. Okay, so there's 2 types of crust. So we've got our continental crust, which is land and it's old, and we've got our oceanic crust composed of oceans and sea, and it's young. So your continental crust is thicker than your oceanic crust and can be up to around 70 kilometers thick. So it usually is comprised of sedimentary formations, which are weaker rocks composed of silica and alumina. And this can be known as seal for short. Okay, so just note that in there. So that's seal for short, your Si standing for silica, and your Al for alumina. So then you have your oceanic crust, as I've mentioned already, and this is younger than your continental crust, and it's also thinner. So they can be about 10 to 5 kilometers in thickness. They're generally composed of more solid rocks, such as basalt, contents of then silica and magnesium here. And with this then, for short, this can be known as CMA. So you've got Cl for continental crust, and you've got CMA for your oceanic crust. Right, so just having a look here at a diagram, kind of going through what we've looked at within this class. And this is the difference, I suppose, from our first lesson when we looked at the structure of the Earth, when you have the picture of the Earth, whereas here you've got kind of more of a cross section. We can see our crust here, about 5 to 100 kilometers in thickness, contains minerals such as quartz and feldspar, found in igneous rocks such as granite, sedimentary, and metamorphic rocks. So this layer here, we'll call it the upper mantle. So this is the lowest layer of the lithosphere, and this is solid. So just looking here, we can see our lithosphere, that part of the mantle of the crust, and also the upper mantle. And we can just see here this line. So this is the Moho line, or the Moho discontinuity. So this is a thin band near the top of the upper mantle, and it marks the change from crust to mantle. So this area we have here then is your asthenosphere. This is the part of the upper mantle that can flow. Beneath that then we have our mantle, which is silica-rich minerals, can be solid and rocky, molten. Below that then we have our outer core, 2,200 kilometers in thickness, iron and nickel, liquid and metallic. And lastly, this area we have our inner core, can be around 1,250 kilometers in thickness, iron and nickel, solid and metallic. Right, just to tie up and finish this lesson, I've got a couple of quick recap questions. So the first one here is, what is the difference between the asthenosphere and the lithosphere? Take 10 seconds. So the lithosphere is the crust in the upper mantle, your asthenosphere is the upper mantle below the lithosphere, and this is where your convection currents are at play. So what is the name of the line between the crust and the mantle? So the line between the crust and the mantle is known as the Moho line, or the Moho discontinuity. Okay guys, thanks for joining us today in this lesson, and we'll see you the next time when we're going to investigate the theories of plate tectonics.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.